Right, behold the high-tech studio that I've had to create for this experiment. I tried to make it so you can see it as clearly as possible. Now, as I said, we can't do sodium because I've done it before. You already know it reacts very violently with water. Plumes of hydrogen coming off it. It's very reactive. It fizzes around on the surface. Gold, as I said previously, won't react. That's why pirates could dig it up from the bottom of the sea, because it wouldn't have reacted over hundreds and hundreds of years. So it's very unreactive. We're going to have a look at these four. We have got iron, calcium, copper, and magnesium, and we're going to react them with just plain old cold tap water. Now we can use the reactivity series to already make some predictions. So I'll just show you over here. We have got iron, we have got calcium, we have got magnesium, and we have got copper. So let's have a look at where we think they're going to go. Starting from the bottom, where we've got copper. Copper's fairly near the bottom, so you should be fairly unreactive. Iron is about halfway up, maybe just to the bottom half. So we'll see. Magnesium is certainly in the top half, maybe the top quarter, and calcium is just above it. So let's see what happens when we react them with just plain old tap water. Go back a little bit so you can see more clearly. So first up, iron. Now, you have seen iron in water before. Think about it, and we'll talk about that in a second. Okay, so I'm going to add it. This is iron filings. Now, telltale signs of chemical reactions happening. Think about them. What do you think? Change of colour, change in temperature, and gas being given off. Now, it's not the most obvious, so I'm going to go a bit closer, because you're obviously viewing on a camera. It's never as good as your eye. But while there might be some air bubbles at the bottom, it's certainly not giving off gas. Okay? Right. Next up, calcium. You probably have heard that calcium is needed for bones and teeth. Let's have a look. So, calcium looks like, I'll show you carefully, looks like that. Okay, so it comes as granules. Remember, it's a metal. I'm just going to pour it in the water. Right, again, let's go closer so we can see. So, you should be able to hear that as well as see it. There's quite a large reaction going off. A lot of gas being given off. You can actually see that the granules are actually giving off so much gas that they're moving around. There we go, and we're definitely off. So that is the reaction of calcium and water. Okay, let's have a look at copper. The calcium one's actually going to get going for quite a while. Let's have a look at copper. Now, you may already know copper is used in water pipes. Now, there's a reason copper is used in water pipes. You've probably already made your prediction from looking at the reactivity series there. Copper is fairly unreactive. That's why we use it in piping. There are other metals which are less reactive, but copper is an inexpensive metal to get hold of that is unreactive. The good old calcium is frothed over the top. So, copper again, we're looking for telltale signs of a chemical reaction happening. I'll move closer, just have a look. Calcium's still going, still having great fun. Not a lot happening. Okay, right. Final one, magnesium. Now, magnesium is just below calcium in the reactivity series. So let's have a look. Right, calcium's still just going. I can confirm if I touch the bottom that there's definitely been a temperature change. It's very hot, it's exothermic now. Copper's still not doing anything, and actually magnesium is not doing anything. So in this experiment, we have no reaction from iron. Calcium was a very vigorous reaction. Copper, no reaction. And magnesium, no reaction currently. There is something to be said about iron though. If I left it overnight, it would appear rusted where iron oxide is developing. So it might react over a period of time. Magnesium will also oxidize slightly. Okay, right. You need to rank them. If 1 is the most reactive, so sodium is definitely going to occupy 1, you need to rank the rest. Remember, this is just with cold water. Off you go.